Yeah. So this is where we left off yesterday, finding the inverse. So the first thing we're going to do today is find the inverse. Do we want to look at 42 or 43? So we can look at 42. Now, guys, focus up here. Thank you. Nice. Now, the first thing we need to do in finding the inverse is to replace f of x with y. So the first step with any of these here is to replace f of x, g of x, it doesn't matter what it is, we replace it with y. Second step is to switch x and y, telling us 7x is equal to 7y minus 4. Now, guys, at this point here, we're going to get y by itself. Now, the order of that I would do the operations, that I would do addition, subtraction first, multiplication, division second, and then exponents and radicals last. Now, we can always reset and continue to go in that order. But here, the first thing I would do is add 4. So it tells us that 7y is equal to x plus 4. The next thing we would do is to divide both sides by 7, telling us y is equal to x plus 4 divided by 7. Now, since y is by itself, we can do the last step, replacing y with f inverse of x. And we get this here. Any questions on this one here? Any questions about 43? So 43 is going to be similar to this here. So the first thing we would do with 43 is to replace g of x with y. Our next step would be to switch x and y, guys. So we replace g of x with y. Our second step was to switch x and y. Now we want to get y by itself. So the first thing we can do is add 7, telling us 2y cubed is equal to x plus 7. The next step is to divide both sides by 2, telling us y cubed is equal to x plus 7 over 2. And last but not least, we would cubed root both sides to simplify the third power. These would cancel, telling us that y is equal to the cubed root of x plus 7 over 2. Now, I'm writing it this way particularly. I'm about to change it because I did see some of the homework assignments written like this. This is not the correct answer. Because are we taking the cubed root of just the x plus 7, the 2, or the whole thing? The whole thing, yes? As it's written right now, you're saying that we're just taking the cubed root of x plus 7, not the entire function. So what we really need, there we go, is that we need that radical showing that it's taking the whole thing, not just the numerator. Because it is possible to write it that way, but we have to rationalize the denominator, which ends up being, if we wrote it that way, would be the cubed root of 4x plus 28 over 2. It's a completely different function. But we don't have to do this. The only other thing is we have to rewrite it as g inverse of x is equal to the cubed root of x plus 7 over 2. Now for this one here, we use g inverse because we started out with g of x. Any other questions on these two here? Are we good with 42 and 43? 44 through 57, solve each equation and check your answers. Now, if it does ask you to check your answers on that there, you're going to need to check them. There are points associated with that. And I also put that in there because if there is an extraneous solution, it helps show you which one it is. Okay? I will state this now, and as it always has been, I do not put no solutions on the test unless I specifically blatantly tell you in the instructions it says that there's a good chance there might be one. Pay attention for those. On this test, there are no solutions. And I'm warning you now, if you do put no solution for one of the solving, you will lose all points for that problem. I'm telling you right now, you will lose all points. And part of the reason I'm doing that is because I've warned you ahead of time. I've told you all multiple times throughout the year, I do not put no solutions. And if you put a no solution, no, but I'm going to just start taking full points for it. Now, when we look at these here for solving, the first thing we want to do in solving is to get the radical by itself. If there's more than one, we even it out. So for 44, we need to get the square root by itself. Well, it is by itself, which takes us to the next step to put both sides to the nth power. And the nth power in this case would be 2, because the square root and square would cancel, telling us 2y is indeed equal to 64. Now we solve for y by dividing both sides by 2, telling us y is 32. Now for this one here, if it did say to check your answer, we just have to plug it back in. So we say square root of 2 times 32 is equal to 8, guys. Now at this point here, we can plug square root of 2 times 32 in the calculator. Second square root of 2 times 32 is 8. So we can say 8 is equal to 8. It checks out. That is the correct answer. Questions on any of this here? Let's look at 45. When we look at 45 again, our first step is to get the radical by itself. So the first thing we can do is subtract 7 from both sides, telling us the square root of y minus 4 is equal to 8. Is the radical by itself? The y minus 4 is stuck inside the radical, so we can't do anything with it yet. But the radical itself is by itself, so we'll put both sides to the nth power. Now the square root and square will cancel, leaving us with y minus 4 is equal to. Then we would add 4. So y is equal to. And if we wanted to check it, we can say the square root of 68 minus 4 plus 7 is 15. Now we can plug, guys, we can plug the entire left side into the calculator. Second square root, 68 minus 4 plus 7, and we get 15. So 15 is equal to 15. It checks out, so 68 is the correct answer. Any other questions on these first two here? Questions on 46 or 47? Which one do we want to look at? 46. So when we look at 46, we want to get the radical by itself. So the first thing we can do is subtract 27 from both sides. And what that'll tell us is that 3 square root of 2x plus 7 is equal to negative 23. Guys. Now at this point here, we can divide both sides by 3, telling us that the square root of 2x plus 7 is equal to negative 23 over 3. Once we did those two steps, is the radical by itself? Yes, there's nothing added to it, there's nothing being subtracted from it, and there's nothing being multiplied in front of it or divided by it. Now this point here, we're going to stop because there's no way a radical can equal a negative. So this one here is no solution. Any questions on 47? Because 47 will be the same as any of these others here, because the first thing we do is get the radical by itself. And in this case, the radical is already by itself. So we can put both sides to the nth power. And in this case, the power would be 3. Now the cubed root and cube will cancel, telling us 2x minus 1 is equal to 2 to the third, which is 8. At this point here, we can solve for x. We would add 1 to both sides, telling us 2x is equal to 9. And last but not least, we would divide both sides by 2, telling us x is 9/2. Now, if we want to, we could check this here. Cubed root of 2 times 9/2 minus 1 is supposed to equal 2. Now I can plug the entire left side into the calculator. Cubed root of 2 parentheses 9/2, guys, minus 1 is indeed 2. So it does tell us that 2 is equal to 2. It just check out, so 9/2 is the correct answer. Any other questions on this one here? Questions on 48 or 49? Either one of these here that we want to look at. 48. Now, since we do have 2 radicals, we need to even them out. So what we can do is add this one here, guys, to both sides. Now what that'll tell us is that we have the 9th root of 2x minus 1 is equal to the 9th root of 4x. Since we have them evened out, we can apply the nth power to both sides. In this case, the nth power is 9. Now since there's only one term on either side, the root and the exponent will simplify out, giving us 2x minus 1. Here, they will cancel out, giving us 4x. Guys. Now at this point here, we can get x by itself. So we can subtract 2x from both sides, telling us that negative 1 is equal to 2x. And last but not least, we can divide both sides by 2, telling us x is negative 1/2. Now, if we wanted to check it, we could plug it back in. It will tell us that this is the correct answer. That's all we have to do on these here. Bless you. Any questions on 48? Questions on number 49? Because cubed roots, odd roots, we can actually get a negative to come out of the root. So this actually does have a solution. It's not no solution. Even roots cannot have a negative come out, but odd roots can. So if we're good with 48 and 49, questions on 50 or 51? Well, we can look at 50. Now there might be a hint on the test, something like this here might show up. So if we solve 50, the first thing we need to do is to get the radical by itself. Here, the radical is by itself, yes? So what we have to do now is put both sides to the nth power. This side over here, the radical and power will cancel, leaving us with 3 minus s. The other side is s minus 1 squared. Well, we could use the hint that's given to us. It's telling us that it's s squared minus 2s plus 1. So we could replace it at this point. We could plug it in. Or if we actually write it out, because s minus 1 squared is the same as s minus 1 times s minus 1. Now, if we multiply this out, s times s is s squared. S times negative 1 is negative s. Negative 1 times s is negative s. And negative 1 times negative 1 is plus 1. Telling us that 3 minus s is equal to s squared minus 2s plus, guys. Well, isn't that just what the hint told us, that s minus 1 squared would be s squared minus 2s plus 1? So if that does show up on the test, I'm providing that to give you all a little bit of a help to be able to solve it just a hair faster. So we could have just gone from here down to here if we wanted. Now at this point, because we have an s squared, we need to get this equal to 0. Now we could add s to both sides first. We could subtract 3 from both sides. It doesn't matter the order that we do it. We will need to do both of them eventually. And when we get it equal to 0, we have s squared minus s minus 2 is equal to 0. Any questions on how we got to this point here? Now at this point here, we can solve it. Now we can solve it by factoring, graphing, completing the square, or quadratic formula. Now if we graph it, I'm going to replace s with x. So we have x squared minus x minus 2. And if we graph this, we get this here, and it does cross the x-axis in 2 places. If we go second graph, look at the table, our 2 solutions are negative 1 and 2. So it's telling us s is equal to negative 1 and s is equal to 2. Any questions on this here before we check these 2 values? Are you ready to check them? So we said s is equal to negative 1 and s is equal to 2. Now if I check 2 first, we'd have square root of 3 minus 2 is equal to 2 minus 1. Now the one on the right, 2 minus 1 is 1. On the left, we could do that in a calculator. We can say second square root, 3 minus 2, enter is 1. So it tells us 1 is equal to 1. So s equals 2 is a solution. It gives us a true statement. We can do the same thing with negative 1. Replace every x in the equation with negative 1. Now on the right-hand side, negative 1 minus 1 is negative 2. We can plug the other side into the calculator. 3 minus negative 1 is positive 2. So it's saying 2 is equal to negative 2, which is not true. So s equals negative 1 is not a solution. It's an extraneous solution. So the only solution that we do have is that s is equal to 2. Questions on this here? So there are some problems on the test where one of them will be an extraneous solution, can be an extraneous solution, but there will not be any where both are an extraneous solution, where we have a no solution. Any questions on 50 or 51? Are we good with 50 and 51? Let's look at the next two. Questions on 52. There is not going to be one like 53 on the test. There was one on previous, but I've removed it. And even if it, and the ones where it was on the test, that was the old bonus question. It's not the same one anymore. I've changed it. So are we good with problem 52? Because 52 will be very similar to 50. Because we would add x and then go from there. If we're good with these two. Questions on 54 and 55. Questions on 54 or 55. Questions on either one of these here. We feel good with both of these here. If you do want to see 55 later, it is in third hours review part 2. So if you do end up having a question on that, you can look there or you can ask. Questions on 56. 57 is a no solution. Any questions on 56 or want to see that one worked? Huh? Yeah. Now, the first thing we need to do is square both sides. Now, we've said before that we can't have an even root equal to a negative number. We can't have an even root equal to a negative number. But v is a variable, not a number specifically. So if the value of v was negative, the negative in the negative value of v would make it positive. So here we can square both sides. The square root and square would cancel, telling us that negative 3 minus 4v is equal to v squared. Because negative v times negative v, the negative and negative would make a positive, and we get v squared. Now at this point here, we need to get this equal to 0. So we can subtract v, or we can add 4v to both sides. Telling us that negative 3 is equal to v squared plus 4v. At this point here, we would add 3 to both sides, telling us 0 is equal to v squared plus 4v plus 3. Any questions on how we got to this quadratic? Now at this point here, we could factor it, use the quadratic formula, or most likely probably going to graph plus 4x plus 3. Graph. We do see that it crosses the x-axis in 2 spots. And if we look at the table, so negative 1 and negative 3. So v, in our case, is negative 1, and v is negative 3. Any questions on how we found these two values before we check them? Now I'm going to check negative 1 first. So we have the square root of negative 3 minus 4 times negative 1 is equal to negative 1. Well, the negative 1 is positive 1. We can plug the other side into the calculator. Second square root, negative 3 minus 4 times negative 1 is positive 1. So it works. Even though v was negative, when we plugged it in, we did get a true statement. We can do the same thing with negative 3. Now, again, the right-hand side, negative 3 gives us a positive 3. Negative 3 minus 4 times negative 3 is both of them give us a true statement that works. So we actually do have 2 solutions. Nice. So again, I did say it in class. We didn't actually come across one too often. But this is one of the problems where both solutions actually work. because here with the negative v by itself, it did take care of the negative case. So it ends up being both of them do work. We're not necessarily having to have one that doesn't work when we have a variable outside of the radical, but there is a high likelihood it would. Any other questions on 56 or 57? We ready for the next set? 58 and 59, yes, we just did this. We already found the inverse once, but we can find another one, 59. Now, I'm including this here, x is greater than or equal to 0, just to make sure, or just kind of we're signifying that the inverse is a function, but that's really it. The steps stay the same. The first step is to replace f of x with y. We don't need to keep this going for the rest of it. And our next step is to switch x and y. So we get x is equal to 7, y squared minus 3. Now we solve for y by adding 3 first, telling us that 7y squared is equal to x plus 3. Our next step would be 2 by 7, telling us that y squared is equal to x plus 3 divided by 7. And last but not least, we would square root both sides, telling us y is equal to the square root of x plus 3 divided by 7. Now, we don't necessarily need the plus or minus for this one. You can add it. But since we were saying that x, the domain, is greater than or equal to 0, the radical here would be positive, the positive case. We wouldn't take the negative case into account. And we'd say f inverse of x is equal to the square root of x plus 3 divided by 7. And technically, we would say x is greater than or equal to negative 3 for this one here. Any questions on this here? Any questions on how we found the inverse for this here? Any questions on 58 or 60? We good with 58 and 60. The last problems, 61 through 63. It's not listed, but it is 63. Determine if the following functions are inverses. If they are inverses, then f of g of x will give us the same value as g of f of x, and they both have to be x. Now, if they both worked out to be 14x, even though they are the same, they are not inverses because they have to be x. Now, it doesn't matter which one we start with, because we can start with g of f of x or f of g of x. There is no set way we have to do which one first. I always start with f of g of x. Bless you. So the first thing we do is plug x into g of x, which just gives us exactly x minus 4 over 6. So we have f of x minus 4 over 6. Now at this point here, we're going to plug x minus 4 over 6 in for every x in g of x. So instead of having 6 times x, we have 6 times x minus 4 over 6 minus 4. Well, here the 6 and 6 will cancel, giving us x minus 4 minus 4. And if we simplify this here, we will get just x, yes? Well, no, negative 4 minus 4 is not 0, it is. So are these inverses? No. Yeah. Yeah, because it doesn't matter what the other one is, because for them to be inverses, both of them have to equal x. Now, is it possible for one of them to be x and the other not? Maybe. I have not come across one that has, but I'm not going to rule that out. because it could be there's just some setup for functions that it does work out that way for one but not the other, but I'm not going to rule it out because I feel like there is one. But any questions on this here? Do we want to look at 62 or 63? So if we feel good with these here, because that is the end of the review sheet. Yeah. F of g of x. Again, the first thing we're going to do is plug x into g of x, which is just replacing g of x with, not x cubed, x squared plus 3 divided by 7. So we have f of x squared plus 3 divided by 7. Now at this point here, we're going to replace every x in f of x with our x squared plus 3 divided by 7. So we have the square root of 7 times x squared plus 3 over 7 minus 3. Now since we're multiplying that entire function or fraction by 7, these 7 and 7 will cancel. If there was more than one term, we would actually have to distribute it, but here they just cancel, leaving us with x squared plus 3 minus 3. Well, 3 minus 3 is 0, leaving us with the square root of x squared, which is x. So most likely this is going to be yes. Now, it'll be good to go on and do g of f of x, do the other one just to make sure. So this time we're plugging x into f of x, which gives us the square root of 7x minus 3. So we have g of the square root of 7x minus 3. Now this time we're going to plug this radical into every x in g of x. So we'll have our fraction over 7, parentheses, square root of 7x minus 3 squared plus 3. Nice. Now at this point here, the radical and the square will cancel, telling us we have 7x minus 3 plus 3 divided by 7. Now 7 divided by 7 would be 1, giving us x. So these would indeed be inverses because we got both of them to equal x. Questions on any of this here? Do we feel good about 63? So that is it. So your test is on Monday. Unfortunately, it is on Monday, so if you do have time over the weekend, Sunday, just to go back through it, refresh, or before you get in here Monday, just to go back over it, make sure everything stays fresh, that would be a good idea. If you do have questions over the weekend, please ask, email me, ask. I will answer them in a pretty quickly fashion. That way, if something you had a question on that you saw, didn't realize today, but realize tomorrow, go on and ask. Also, all of your homework is due by the end of the day Monday, so anything you have missing needs to get turned in. Otherwise, it will be a 0.